Okay, good afternoon, everyone. I hope you are doing well. So today we'll start with the sixth chapter of RFT, that is EMC, which stands for electromagnetic compatibility. Electromagnetic compatibility concepts. I would like to introduce about electromagnetic interference. We have already studied the concepts of electromagnetic interference in chapter 5. Still, I'll give you a brief introduction about electromagnetic interference. So under this chapter, electromagnetic compatibility, which is the sixth chapter of this subject RFD, the things that we are going to study are concept of electromagnetic compatibility, what is electromagnetic compatibility, and why it is required, especially when we are designing product. And then how one can reduce the noise in the existing systems. Several techniques are there in reality to reduce the noise or electromagnetic interference in the system. Some of the techniques are grounding, shielding, bonding, filtering. These are some of the techniques using which one can reduce the noise in the system or equipment or any device. So we'll be studying those techniques, how these techniques are useful in reducing the electromagnetic interference or noise in the system. Then we'll be also studying the EMI diagnostics and fixes and the standards. There are several government agencies, regulatory bodies are there. They are defining their emission levels, threshold values of different parameters for different devices. So one should design their device in such a way that their device should not produce parameters that are exceeding the threshold parameters defined by those government agencies or regulatory bodies. So we'll talk about those regulatory bodies also. Many regulatory bodies are there. However, we'll be discussing only about military standards, which is MIL stands. It is written over here. You can see in the screen. This is FCC and this is PER. So we'll be talking about only these three standards. However, several other standards are there, but in your syllabus, these three standards are included. So we'll be restricting ourselves to these three standards. So before starting with the concepts of electromagnetic interference, I wanted to tell you something about electromagnetic interference. We have already studied electromagnetic interference in chapter 5. In fact, you have given a quiz also based on electromagnetic interference chapter. So we'll study what is this. Briefly, I'll give you an introduction about this electromagnetic interference. What is this electromagnetic interference? This electromagnetic interference is nothing but a noise. Now, noise everyone knows. What is noise? Noise is nothing but an unwanted, undesired electrical signal that disturbs the performance of the system. Now, what are the sources of this electromagnetic interference, so-called noise? There are many sources. However, the sources of electromagnetic interferences or noise can be broadly classified into two types. That is a natural noise and a man-made noise. What is man-made noise? This man-made noise is nothing but the devices which generates electromagnetic interference or noise, which are man-made, are man-made noise. And natural noise, the natural noise occurs because of natural phenomena. So what are the devices? When I'm talking about equipment noise or man-made noise, what are the devices which generate noise? In reality, all devices generate noise. What is noise? As I have mentioned, it is an unwanted, undesired signal that may disturb the performance of the device. So when I'm talking about wired system or any equipment which is generally consisting of conductors, so when a current is flowing through a conductor, what happens? Electric field and magnetic field will be produced by the conductor. Ideally speaking, the conductor should not produce any electric field and magnetic field. So, but due to the Faraday's law and all, we know that whenever current is flowing through a conductor, it produces a magnetic field. And that magnetic field may induce into the neighboring equipment. And that may affect the performance of the neighboring equipment. The magnetic field getting induced into the neighboring equipment is nothing but a noise. So we have to reduce those noise. using several techniques. So that is the equipment noise. So different equipments offers different level of electromagnetic interference that depends on the type of component that you are using in your equipment. So what are the various components that you will be using in your devices, in any electronic device? Cables are there, right? A simple cable that acts as a transmission line. If the cable length is comparable to wavelength, the cable itself acts as an antenna. It may radiate energy into the space and it may receive energy from other devices also. That is very, very bad thing. So cable length should be as small as possible, so that cable, if it is much smaller than wavelength, it will act like a Hertz dipole antenna. You might have studied antennas in ARWP subject in 6th semester. So if antenna dimensions, any antenna dimensions, if it is much smaller than wavelength, then that antenna is called as Hertz dipole antenna. What is the characteristic of a Hertz antenna? Hertz antennas are those antennas whose maximum dimensions are, or largest dimensions are less than lambda by 10, and they are not good radiator because the radiation resistance offered by that antenna is very, very less. So it is not radiating good power into the space, and it is not receiving very high power from the transmitters. So they are not a good antennas. But please remember, there are some devices which are very sensitive in reality. So even the small power received by that cable, which we are using in connecting the components in circuit, acts as a Hertz antenna. That particular power is capable of destroying the device. Sometimes it may happen depending on the sensitivity of the device. Some devices are very sensitive. So if your device is very sensitive, even a small power received by the cable can damage the entire circuitry and can affect the performance of the system significantly. So selection of the cable is also a very, very important thing. Apart from the cable, a lot of other circuits, when a noise will be significant, please remember, noise will be generated. Noise is nothing but electromagnetic waves. It can be in the form of electric field or in the form of magnetic field, or it can be a combination of both electric and magnetic field that is forming electromagnetic wave. How a noise can be generated, or when the noise will be significant. So noise will be significant whenever there is a abrupt change in the voltage or current on the circuit. And when it is possible, when I'm using devices like oscillators, switches, SMPS, switch mode power supply, motors, relays, what happens in these particular components? Switch, for example, if I'm taking switch, how it works? When the switch is in on state, current will flow from one circuit to other circuit and some output will appear on the other end of the circuit. If switch is in off state, nothing will appear on the other. So when I'm turning on the switch, what is happening? A high current is flowing. When I'm turning off the switch, I'm open circuiting the switch, so current is not flowing. Very little current, no current is there in fact. So abrupt change in current or voltage is happening in switching operation. So whenever there are transients means input will be there only for certain time instant, and those kinds of transients, or whenever there is a making and breaking of a circuit is happening in the equipment, produces transients, and those transients are capable of producing radiations. What is the requirement of radiation? You have studied in ARWP. A wire will radiate only when it is excited by time varying source. Even if I am applying DC source, but I am using switch, so what will happen? DC source doesn't have any time variation, but I am using switching operation. Due to switching operation, there is a sudden change in the amplitude of the current and voltages is happening due to the switching operation, and which causes the variation of current and voltage with respect to time, and which generates electromagnetic waves. That is nothing but interference, and that interference may induce into the neighboring equipment and may destroy or change the performance of the neighboring equipment, and that is not desired thing, right? Similarly, this is the equipment noise. All equipment generates noise because all equipment consists of conductors, metallic objects and all. So whenever current is flowing through conductors, metallic objects, it produces electric field, magnetic field, electromagnetic waves. Those electromagnetic waves may get induced into the neighboring equipment and they may change the performance of the neighboring equipment. And that is not desired thing. So to avoid this, several techniques are there. We'll discuss those techniques step by step. Slowly we'll go into that part. But other sources of noise is natural sources, like lightning is there, which is a natural phenomena. ESD, electrostatic discharge, atmospheric noises are there, galactic noises are there. So those are the noises generated by natural phenomena. So those noises are also capable of damaging the equipment and capable of changing the performance of the equipment. So how to control this noise? How to make a device which is compatible to electromagnetic interference? There comes the concept of electromagnetic interference. So what is electromagnetic compatibility? Electromagnetic compatibility is nothing but the ability of a device to function effectively in electromagnetic environment, and at the same time the device should not emit radiations into the surrounding that may affect the neighboring equipment. I hope it is clear. What is electromagnetic interference? It is the ability of a device to function effectively without degrading the performance of the system in electromagnetic environment, because whichever device you are designing, it is surrounded by electromagnetic radiations, which is nothing but noise. We have several wireless systems surrounding to us, like Wi-Fi, mobile communication, satellite communication, radar and all. So we are surrounded everywhere by electromagnetic waves, which is nothing but a noise. We have so many appliances at home, so many equipments everywhere in our surrounding. Whenever current is flowing through those equipments, it produces electric field, magnetic field. The conductor produces electric field, magnetic field. Some conductors may produce electromagnetic waves depending on their length and all, right? So those devices are generating noise, and your device that you have designed should be capable of working effectively in that interference environment. Then I can say that the device is made compatible to electromagnetic interference. I hope it is clear. And at the same time, you should design a device in such a way that the device should not emit radiations, should not emit noise into the environment. That noise may disturb the performance of other devices. So it should not emit the noise, or the noise or the electromagnetic interference generated by the device you have designed should be within the acceptable limits defined by the regulatory bodies or government agencies. So the electromagnetic environment is, as I have mentioned, is composed of two types of energies: radiated energy and conducted energy. Conducted energy, the equipment noise. Whenever a current is flowing through any conducting material of an equipment, it produces electric field, magnetic field. That is a conducted emission, and that may disturb the performance of any other devices placed surrounding to that equipment. So that is conducted emission. That is happening because current is flowing through a conductor and it is emitting electric or magnetic field or electromagnetic field. So that is the emission happening through conduction process. Now second type of emission that can happen through radiation process. How radiation occurs? Which are the devices which can generate radiation? Antennas. So if I have antennas, antennas are meant or designed to radiate energy into the space. So that radiation is intended radiation, desired radiation. However, the conducted emission is undesired radiation. Please try to understand this. Whenever you are designing any equipment, it is comprising of a lot of conductors. When current is flowing through those conductors, it will produce electric field and magnetic field to its surrounding. That is undesired thing. And I cannot have a control on those fields because those are inherent properties of the conductors, right? So that is a noise which is undesired noise. While when I'm talking about antennas, they are designed to radiate energy into the space. They are generating electromagnetic waves. That radiation is intended or desired radiation. But again, we should design your device in such a way that the radiation generated by surrounding antennas operating at different frequencies for different application should not affect the performance of your device. When you are designing your device has to go through several tests, and your device must pass those tests so that you can launch your device for commercial applications. We'll talk about this in greater depth a little later. So what I wanted to tell you is there are two aspects coming into picture due to these two radiations, conducted emissions and radiated emissions, and the emission and susceptibility. What is this susceptibility? Its name itself indicates susceptibility. What is susceptibility? Is the ability of a device or a circuit or an equipment to respond to an unwanted energy, unwanted signal, unwanted noise. So device, whenever you are designing any device, that device should not respond to any electromagnetic interference coming from other equipments. I can say that if it is responding to those interferences, then I can say that your device is susceptible to electromagnetic interference. It is not working good. So if your device is susceptible to electromagnetic interference, nobody will purchase your equipment, right? Because it is not working good in electromagnetic environment. So you should design a device that is immune to electromagnetic interference. So there is other term called as immunity, which is exactly opposite to susceptibility. What is immunity of a device? Immunity of a device is nothing but the ability of a device or an equipment to work satisfactorily in electromagnetic environment without affecting the performance of the device. So how to improve the immunity of a device? The emission, the radiation generated by the device should be controlled so that one can make the device less susceptible and more immune to the electromagnetic interference. So controlling the emission from one product may eliminate an interference problem in many other products. Therefore, it is desirable to control emission so as to make the device compatible to electromagnetic environment. So what are the techniques using which one can reduce the electromagnetic interference or emission, which is in the form of conduction and radiation? So several techniques are there, as I have mentioned earlier. The 4 techniques which are commonly used for reducing the noise or electromagnetic interference generated by the devices and generated by the natural and man-made sources: the grounding, shielding, bonding, and filtering. Please remember, filtering is not there in your syllabus, but it is really very important concept in reducing the noise level in the circuit, especially when I'm dealing with common mode noise and differential mode noise that you have studied in chapter 5 EMI. Filtering is required. So grounding, shielding, and bonding, these are the only 3 techniques which are there in your syllabus to reduce the electromagnetic interference generated by man-made sources and natural sources. In addition to these techniques, some other techniques like conducting gaskets, surge arresters, transient suppressor, isolating transformers, and all we can use to reduce the electromagnetic interference. So what are the standards, the regulatory bodies, the government agencies that are controlling the emission levels generated by the devices? See, whenever you are designing any device, that device has to go through several tests, as I mentioned earlier. So different governing bodies are there. This CISPR, then FCC, and military standard. These are the 3 standards that are there in your syllabus. They define several thresholds for several different parameters, and several different tests are there for different devices. So the device that you are designing has to go through those tests, and your device must pass those tests. What are those tests telling us? Those standards generally define some threshold values of parameters. The voltage or the EMI or any other parameter generated by that device should not exceed the threshold defined by those governing agencies or regulatory bodies. If it is exceeding those levels, you cannot launch your device for commercial application. So when you want to earn money by launching your device in commercial applications, your device must pass these tests. So we'll talk about this test a little later, because that is the end of the chapter. So electromagnetic compatibility should be taken into considerations in the beginning of designing of the device. When you are thinking of designing any device, at the beginning, when you are doing literature survey, that time itself, we should try to identify the sources of noise that can, or the components or the layouts that may generate electromagnetic interference. You should try to identify those sources that can generate electromagnetic interference in your device, and you should design the device wisely so that those sources of noises can be reduced. In the literature survey part only, you can reduce the noise to a great extent by designing an equipment or a prototype properly. So designing of a prototype is also a very crucial thing. You should design it wisely so that, for example, if I'm designing any device, if I'm having two conducting wires like this, they are placed very close to each other, and I'm designing this particular device to operate at very high frequency. So obviously, when current is flowing through one conducting wire, it will produce some magnetic field. That magnetic field may induce into this another conducting wire, and that will give you mutual inductance, which is not desired. That may affect the performance of your device. So you should initially, while designing itself, you should separate the two conductors by sufficient distances so that the coupling between the two conductors, magnetic coupling that is happening between the two conductors, can be reduced to a great level so that the device is made compatible to electromagnetic environment. It's here itself. Otherwise, later if you try to incorporate EMC into your device, we have to add additional circuitry into your device that will not add the cost into your device, but also it will increase the spacing required for your device. So that is not a good thing. So this graph clearly shows that we are having large number of techniques to control electromagnetic interference in the beginning of the designing of device. And when I'm in product phase, first I'll be designing the device on breadboard, then I'll be designing it on PCB, then I'll be trying to convert that PCB, that prototype, into a product. I'll be offering some kind of casing to the device. That is product phase. So when you are not considering EMI in design phase, when you go for testing, certainly your device will fail those tests and your device may not be allowed to launch for commercial applications. So then you have to add certain shielding things in your device to reduce that electromagnetic interference, and that will add the cost and size of the device. And that time you will may not have more number of techniques to reduce the interference that is happening within the equipment. So it is always recommended to consider EMI in the beginning of the designing phase, not at the end of the designing. So how to measure these emissions? As I have mentioned, two types of emissions are there: radiated emissions and conducted emissions. How to measure this? Radiated emissions, these are the emissions generated by antenna elements, and conducted emissions, these are the emissions or electromagnetic interference generated by any conducting object that is there in your equipment. So radiated emissions, to measure these radiated emissions, we require something called anechoic chambers. You might have seen anechoic chamber that is there in Samir Kharghar. You have recently visited Samir Kharghar branch. They have something called anechoic chamber. Anechoic chamber is a room where the environment inside that room is quite uniform, and a microwave absorbers are placed on the walls of those rooms so as to avoid the multipath propagation and to avoid the fading, so that one can measure the performance of the device effectively. Please remember, those testings are very expensive because anechoic chambers cost is in crores. So testing of this emission generated by antennas is very costly thing. So how to measure the emission generated by your antennas? So the operating frequency must start from 30 megahertz, and the highest frequency should be the highest operating frequency of your device or antenna under test. So you can use anechoic chamber, you can use GTM cell. GTM cell is again very similar to anechoic chamber, only the shape of GTM cell is just like a pyramid, nothing else. And they will be having a standard horn antenna or any dipole antenna. Generally it is linearly polarized, can be used to measure the radiation produced by the antenna elements. Similarly, to measure the conducted emission, one can use a device called LISN, that is line impedance stabilization network. That equipment is again very costly equipment, which can be used to measure the emission generated from the conducting wires. And please remember, this emission does not exist away from the conductor. This emission is existing very close to the conductor, because this emission is generated by a conducting wire whose length is much smaller than wavelength. So they are not good radiators. These are cables, transmission lines. So this emission will be very less. So this emission has to be measured in near field. while the radiated emission has to be measured in far field. So these are the measuring techniques. Again, this LISN device and a special spectrum analyzer is required for measuring this conductor emission. So these devices are really very expensive. That's why in Mumbai, I guess there are only 1 or 2 agencies which are offering these measurements. And whenever you want to launch your product, you have to measure these radiation levels, then only you can launch your product. Now, to understand the concept of grounding and shielding, I'll slowly try to incorporate the concept of grounding and shielding, so that it will be easier for you to understand the concept of grounding and shielding. As I have mentioned, grounding is to reduce the electromagnetic interference. What exactly you do when you are grounding any object, any material? You are grounding any point means you are making potential at that particular point to 0, nothing else. And what is grounding? What for grounding is required? For equipment safety and as well as for safety of the human beings from the lethal electric shocks, right? So what is the meaning of the grounding? Grounding and earthing are the same things. Grounding means we are simply making the potential 0. If I am grounding any conductor at any point P, that means I am simply making the potential at that point P to 0, nothing else. To understand the concept of grounding, let us consider an example. I have 2 concentric spheres of radius R1 and R2. You can see over here. So assume the 2 concentric spheres of radius R1 and R2 we are having, and assume the charge on the inner sphere is say plus Q, and we don't know what is the charge on the outer sphere. So let us say the charge on the outer sphere is Q dash, which is an unknown charge that I don't know, and we have to find out that particular charge. So what I'm doing, I am grounding. You can see over here, I'm grounding outer sphere at this particular point P. I hope you can see this figure X. We have grounded this outer sphere at point P. We have grounded this outer sphere at point P means the potential at point P is becoming 0. That means Vp is equals to 0. You can see, right? And we have to find out the unknown charge that is there. Please remember, when I'm saying the potential at point P is becoming 0, it doesn't mean that the charge on that outer sphere will be 0. Charge will not be equals to 0. Potential at that point is equals to 0. So we'll talk about it. So Vp is 0 at point P. So we can see what is the total potential at point P. The potential at point P is due to 2 charges. The one charge that is Q dash, which is unknown charge, and the other charge which is there on the inner sphere, which is plus. What is the definition of potential, or what is the potential due to a point charge? Now I want you to recall EE concepts, electromagnetic engineering concepts. Potential due to a point charge Q is at a distance R is given by Q divided by 4 pi epsilon R. I hope you remember this. To understand this electromagnetic compatibility chapter, you need to have a lot of basics of electromagnetic engineering. So what is the potential, net potential at point P? Net potential at point P is due to the potential of plus charge Q and potential with charge Q dash, which is there on the outer sphere. So potential at point P due to charge Q that is there on the inner sphere is K, which is nothing but 1 upon 4 pi epsilon. So Q by 4 pi epsilon R2. R2 is the distance from the center of the sphere to the point P, plus Q dash divided by 4 pi epsilon R2. So this is the potential due to the charge that is there on the outer sphere. So total potential is addition of these 2 potential, and this potential is nothing but the net potential Vp, and we are grounding that particular point P, therefore it is equals to 0. So I'm simply rearranging this expression, simply shifting the second term to the right hand side. What I'll get, Q is equals to minus Q dash. What does this indicate? The outer sphere will have same magnitude of charge but opposite polarities.